You might notice one error left in our setup processor. Go back up here, and if you remember about create cannot connect prompt, pause the video and copy paste this method right down here, and that should be the last thing that we need. So when you're done with that, add a new class for your update processor. Now that we are ready to start on the update processor, we will need a new class for that, as we have just made. You should be able to follow the steps previously from the discovery processor to add the class and annotate it with configuration default attributes and override the isLicensed property to temporarily disable extension licensing. You won't have to configure your NuGet source, as that only needs to be done once per project. What does this look like? We will soon see. Public class, which inherits from processor. You can copy paste the isLicensed into here. And don't forget to implement the abstract class. Your update processor will require the following inputs in order to perform its intended function: a server name, username and password, API key, update current conditions as a bool, and update forecast as a bool. Knowing what we know now about attributes, it should not take long to do this. So we go into discovery processor. We can copy this over, but we're only really interested in username and password. This next section is sped up for your convenience, but after you get username and password, you just need to add API key, update current conditions, and update forecast. Hopefully, you will look at this code and your own particular warning bells will be going off. 3 of the properties we needed in the setup processor, we need again here. Furthermore, we're going to need a data adapter instance just like we did in the setup processor, and some common validation and cleanup. Perhaps some refactoring of our code is in order. Let's start by creating a new weather processor base class. It's going to be holding these properties so we don't have to keep repeating it. So look over to the right pane right here. You can see that I've already provided one. In weather processor base, we already have several things such as licensing, and we'll go down here in a little bit. After I correct the namespace, we have licensing, and we also have our data adapter as well as our properties and validation and is connected. You can slowly go back through this part of the video to see what you need to copy over, but in general, this class will be inherited from by both our processors so that we don't have to repeat ourselves. So the next step that we need to do is edit our own code, but by edit, I mean just do some quick and easy removals. As for our lazily instantiated data adapter, only the setup processor should create the EWS server. So the update processor is not going to have any of that data adapter stuff. It is just going to only connect. So I'm going to remove the redundant code from setup processor and keep only the regions that it needs. You can pause the video after this sped up section and make sure that your class looks like mine. And lastly, we are now inheriting from weather processor base. Only these regions should be left in setup processor. So now we can go back into the update processor and delete username, password, and server name. And inherit from weather processor base. Congratulations, we've successfully refactored. Now we can go directly into the update processor functionality in the execute subclass method. From the requirements, we can stub out the functionality we need with comments as we did previously. Make sure we can connect to an EWS server. Retrieve current value item. Perform updates and return any issues. Let's review what we did. So make sure that we can connect. The current city will be the first or default. Where item X's alternate ID is our same as the server helper's city ID. If the current city is null, we will return a custom prompt, which you will see here. Let's review what we did. We want to make sure that we can connect to an EWS server. We're doing exactly what we did in the setup processor. If there's no server and is connected as false, then we will just report that via a prompt and exit. Next, we retrieve the current city value. It retrieves the EWS value item from our data adapter instance. If there is no item, e.g. current city equals null, then we just report that via a custom prompt and exit. Then we perform updates by calling doUpdates. If this method fails to perform the updates for current city, we want to make sure our EWS data can report that condition. This was a requirement enumerated earlier. Before we get to that, let's write the actual update code. Since the update processor can be configured to update either the current conditions and or the forecast, we can write that method as shown now. If updating either the current conditions or forecast fails, we'll return that to the calling routine. So let us make a region for our new doUpdates method. So if we have updated the current conditions but not performed that update on the city ID, then we are returning a false. We can copy and paste this for forecast. And the methods we are stubbing out, of course, do not exist yet. Update forecast. And of course, by default, we return true. So we will start with that method first. And like every method, it requires its own region. So this right here, we are about to begin working on it in the next video.